All right, our next step is to flip the part flip the part to just do the chamfers on the other side of the holes. And we have a choice. We can either flip this about the x-axis, which would put this face on the fixed side of the jaw. Problem is this surface has got a loose tolerance on machining it, and if we end up smashing the part a little bit, that position is going to be off in the y-axis for these holes. So our dilemma is to keep this flat against the fixed side of the jaw, we need to flip the part about y. And then what we'll end up doing is probing this side just for our x-axis. And if we use a different offset number when we program it, then we could still leave the original one there. But if you're only making one piece, you're just going to probe the x-axis when you do your origin for this next operation, and then you can use the same parallel heights and the same Y position. Okay, so I'm going to hide this instance of the vise. I'm going to elect to flip this around the y-axis. We're going to bring in another version of the vise. That's also going to be on 1 1/8" parallels. Okay, and then we're going to rotate the vise in orientation to where we want it. Just 90 degrees. Physically move it. To be below the part. We're going to hit OK. We're going to assemble a joint. We're going to use the width again. We're going to pick both ends of our vise jaw. We're going to place our snap point in the center of the parallel. And then we're going to do the width on the block. And our snap point is going to be the center bottom edge. Okay, that should snug into our vise. Okay, you want to make sure you double check there's no gaps or anything. And then we're going to change the width to 1.225, just like the last operation. And again, this operation is just doing the chamfers on the hole features. Then we have our last operation, which we need to stand up on end to do this this hole here. Okay, so that is going to be a different scenario. We're going to hide the vise, and we're going to orientate the part like so. We're going to clamp on this face and this face. It's somewhat semantics on which side the flat's on, but I'm going to put it on the left, and we'll probe on the left side of that. But this part is so tall that I don't want to risk fixturing tying that to a stop that was set way down here. You're going to have to work in the lab to get this square. There's a couple methods we can use. We can verify it with an indicator, and we can use 1, 2, 3 blocks and whatnot. But this is a pretty tall part to be putting in the vise, and with our current tooling, so it's not exactly ideal. So we're going to bring in our last instance of the vise, and we're going to use the shortest parallels we have available, which I believe is the 1/2 inch. We might have 3/8, so make sure you check that you actually put 1/2 inch parallels when you set this up. We may have 3/8, but at the time I recorded this, we don't have that size modeled in the vise. Okay, we're going to hit OK. And we first need to rotate our vise 90 degrees. And then we need to move it down. Okay, we're going to hit OK. And for this, we're going to do a joint. And we want to clamp on center. The reason we're using parallels is, see, this is a sheet metal cover, and there's a gap in the mirror. And the vices work better if we clamp towards the center of the vise, because this back jaw can spring sideways. And these two surfaces are machined flat. But what the parallel is for is you don't know if you actually have this seated flat without the parallel being there and tapping it with a hammer. And if the parallels don't move, then you truly have the part seated against the end flat. So we do want to use parallels. There's a rare occasion you're going to never use parallels. So we want it roughly centered and it has to be identically centered. So with this shape, we get a little bit of a challenge there. We're going to do the width selection again on our width of our jaw, and then we're going to go down and put our snap point on the center of the parallel. And then on the other component, just going to snap it to an origin point that is the center of the edge, horizontal edge, and that'll be close enough to center as far as concerned on the vise. Again, we're going to be setting our origin using the probe and in the machining software, so this is somewhat visual for the setup person. So we got it close enough to centered that you're going to get even pressure. And we'll hit OK. And then we need to put it 3/4 of an inch thick. Alright, so now we're set up and we're pretty much ready to go and start programming this. Okay, so we're going to switch over to the Manufacture tab. And in the Manufacture tab, we're going to hide this instance of the vise and go to Operation 1, which just looks like this. And for Operation 1, we need our stock visible. The Operation 1 again is going to skim the top down. We're going to profile around the part, and then we're going to deburr the back of the part. Okay, we're going to go to Setups, and we're going to make a new setup. And we're going to go to the Stock tab, and we're going to base the stock from solid, and we're going to pick on our solid of the stock. Then we're going to go back to Setup, and we need to select what is the actual part. So we're going to select the part and select our body that we labeled with the part number. Okay, so that should get our stock to the correct size. Now we need to Z-axis plane and X-axis. Pick on the top of the part, and then we're going to pick on one of the horizontal edges that's in the X-axis direction so that the red arrow is pointed right, green away from us, and Z straight up. Now we can go to box points, and we're going to set our origin. So for the first op, we'll always base that off a stock box point, and we're going to use the lower left corner. There's some philosophies where you always use the top. Problem with that is, as you cut your parts and they vary in thickness, you got to keep adjusting every operation. If we pick the lower bottom, everything is cut to our fixture, and you'll have consistent heights, and then when we can reuse that origin location work coordinate system on the machine with a vise stop without making a whole lot of adjustments. So in this case, our X and Y coordinate will stay the same for the first 3 ops. At that third op, we will have to adjust the Z height. And then we have our last 2 ops that are going to have their own origins. It's less of an issue with probing, but still, even with probing, every minute you spend probing, your machine is not cutting parts. So the idea is to get your setup, dial it in with the probe in a fixture, and then you're just loading parts in and out without probing cycles. Okay, so now we're going to go to the post-process tab. We're going to call this 7310, which is the part number, op 1, so we'll put a 1 on the end. And we're going to call this op 1, and we're going to use work coordinate system 1 unless it allows you to pick 54. For a Haas, the first offset is 54. Alright, we're going to hit OK. And we've set our setup. We're going to change the setup name to op1 so it's consistent with what our program is going to be called. And now we can start programming. So like our similar parts, this should be not the first part you've done in this class, so I'm going to go a little bit faster. We're going to first face mill this with the 3-inch face mill. So we're going to pick the face mill command. We're going to select from our aluminum library the 3-inch face mill. One footnote, if you have the wrong version of the tool library, this is going to show a slower RPM. You want it at 3,000 or higher. We're going to keep all the feeds and speeds at default. We're going to go to geometry, verify it's selecting the face we want to machine. We're going to go to heights. We're going to leave all of this at default. You're cutting to the stock at this point. We're going to be cutting from stock top to model bottom. So, or I'm sorry, model top, which is the difference between the light blue and dark blue planes. We're going to go to passes. On passes, I want to increase this pass extension. And the reason is our stock could be up to 100 thousandths longer than what it's theoretically modeled here. That was in the saw operation. It gave them 100 thousandths of tolerance. So we're going to go 1.7. We're going to give it a couple more 100 thousandths to plunge straight down. And that way it doesn't contact the part. It's plunging straight down in air. Now in the linking tab, we're going to make sure the keep tool down is selected. And we're going to keep everything at default except for, if you know me, I don't like vertical lead-ins. So there is a way if you want to set it so that something has got a default setting. You can pick on over on the right of the field and pick on the 3 dots. And you can save this as your user default setting. I'm not going to do that because this is the default settings for Fusion, and that's what you're going to start with as a student. Feel free to change that. I'm going to be having you put 0 in that field for most routines. Okay. Okay, we've got our face mill. It's going to come down on the right hand side, which is good. We can see the cutter approach, and the cutter rotation will be going against the fixed side of the jaw, and then it's going to pull up. If yours isn't, you can always open the parameters and tell it to cut from the other direction. Pretty straightforward. Now we're going to start machining the model, so that means we need to hide the stock that we modeled, and we're going to machine around the outside perimeter of this part. There's not a lot of material coming off here. It's less than 1/4 of an inch. It's about 1/4 of an inch per side at the heaviest places and about 50 to 100 everywhere else. I don't think it's worth doing an adaptive for this. We're just going to go in and do a contour, 2D contour, and we're going to use the 1/2 inch end mill for this. We want a nice stout cutter. So we're going to pick from our aluminum library the tool number 2, which is a 1/2 inch end mill. And then we're going to go to the geometry tab, and we want to cut down, we want to cut this perimeter I've highlighted. We're going to cut that profile, and if you notice, it projects it down to a plane that is at the lowest point of the actual model. That's what we want. And you want to verify the arrow is on the outside of the line. If it's not, you double click on it and it'll cut the opposite side of the line. But if it wasn't the opposite side of the line, you basically machine your part away. We don't want that. Okay, we're going to go to the heights tab. We're going to change the stock top settings to model top, because we've already machined 30 thousandths off the top. That'll just lower these planes a little bit. And our profile is going to cut to the selected contour. Okay, so by default. But we want to cut a little bit past. We have a plus or minus 10, I believe, tolerance on this height. If this was cut at the high, we'd be left with a little bit of flash where my cursor is by the radius. So, to avoid that, we're going to put in negative 10 thousandths. Okay, make sure it's 10 thousandths and not 100. We don't want to run into our steel jaws. Okay, we're going to go to passes. We're going to do compensation where that allows the operator to use cutter compensation. We're going to leave a lot of this at default till we get down to the next boxes. We do want a roughing pass, and once we click that, if we go back up, a box appears of step over for your finish pass. So right now it's going to leave 50 thousandths for our finish step over. We want to actually tighten that up. Right now, there might not even be 50 thousandths left on the ends, so it might be just cutting air. But we also are going to have a lot of engagement on the flute at the final cut on here, so we don't want to be taking too much off. So we're going to change that to 10 thousandths. So the rough cut's going to leave 10 thousandths to remove by the finish cut. Okay, our roughing passes box. We have a maximum step over 475 thousandths. This number doesn't matter if this step over is only 1. If it's more than 1, then this number is how far away those roughing cuts will be from each other. So we're just going to leave that at default. And we're going to go to multiple depths. And maximum roughing depth, I don't want to go that much. That's almost an inch. Let's go 0.25. That's about half the diameter. We're going to do one finishing step down at the bottom. We can leave the default at 8 thousandths. That's actually going to act more of a spring pass. So that any cutter flex, it'll do a slight skim cut. Especially because this is pretty deep. It's at the limits of what our flute length is. Okay, we're going to leave that at default, approach method at default. We are going to finish only at final depth, and that's one reason we wanted to reduce the amount of material being removed. And we're going to use even step downs. And don't worry about order by depth or islands. That only comes into play with pockets and multiple features. Okay, we're going to leave everything else at default, except we're going to check the smoothing deviation. That might help in these radiuses. It's 4/10. It's good. Alright, so in the next tab, we're going to pick the Keep Tool Down tab. Make sure that it doesn't pick up between each pass. We're going to keep our horizontal lead-in radius. The sweep angle's fine, and the linear lead-in is fine. We do not want to do vertical lead-in radius again. Not really a purpose for it, since we're not really cutting a floor per se. And we do want to select our preferred entry point. So I like to put it, if we can, where the operator can see it, and you can see what's going on. So we're going to pick preferred lead-in location and select one of these endpoints here. Okay, and that way it'll start on that corner and have less chance of a gouging effect. Is that okay? Okay, so we have our lead in and lead out. It's going to be on that corner. And then we do our cuts, and at the bottom we've got our finish in Z, which will act as a spring pass, and our finish in X and Y, which will take it down. We should have just enough flute length. This cutter is got 1.5 inches of flute length, and again our height is 1 inch, 225. So that should be within reach for this cutter. All right, next we're going to do our chamfer mill around this outside perimeter. Okay, so we're going to go to 2D chamfer, and we're going to select from our library the 3/8 chamfer mill. Please use the 3/8. We're going to stop using the 1/4 inch because in the next in the fall we're removing that tool from the library. We need to make room for other tools. Let's hit select, and now we're going to take the default feeds and speeds, and on geometry we can just pick the plane of the bottom of the part. We'll get the perimeter, and we're going to go to heights. We're going to change these to model top for both. We're going to leave the rest of this at default. We go to this tab, we're going to do wear compensation, and our chamfer width is going to be 0.009 because remember our note says it can be 10 thousandths max. Let's go ahead and pick our smoothing deviation, should be 4/10, and then we go to linking tab. Just make sure there's no vertical lead-in radius. I don't think it puts it in chamfer mills anyway. And our preferred start point is going to be in the same place. And hit OK. Okay, and so we get our small chamfer mill rolling around. Right, that is the first operation.